Today I will explain question 2, question 4 and question 6. Now we go to the question number 2. Okay, first we move to the line number 1 is move EAX X1 NEG EX. So the value 26 is moved to EAX register, then the NEG instruction change the sign of the value. So EAX equal to 26. Then move, go to the next Y val and Z val. Move EBX Y val and sub EBX Z val. This shows the calculation EBX sub Y val sub to Z val. So 30 minus 40 equal to negative 10. So EBX equal to negative 10. Okay, then add EAX EBX. So the calculation is negative 26 plus negative 10 equal to negative 36. So EAX is equal to negative 36, and then INC EAX that calculate INC instructions increase EAX by 1. So the calculation is negative 6 plus 1 is equal to 35. So EAX is equal to negative 35. Then move R val EAX. Then the R val EAX is stored into the R val. So R val is equal to negative 35. Okay, so the final result of R val is 4294967261. The final result is negative 35. However, the wash window displays is 4294967261. Both values represents the same 32-bit binary pattern FFFFFFFFDDH. Interpreted as signed, it is negative 35. Interpreted as unsigned, it is 4294967261. Okay, now we move to question number 4. Okay, first I will explain the variables that we declare in the data section. First we have var1 is initialized with value 40, var2 is initialized with value 10, and var4 we currently uninitialize and we will be used to store the final result. Okay, at the bottom left side shows that our variables that var1, 40, var2, 10 and var4 is currently 0 because has not reached the instruction that stores the result. Okay, then we go to one by one. Line 1 first. Okay, line 1 shows that move AX var1. This instruction occupies the value of var1, that 40, into register AX. So since var1 is 40, after execution we see the AX equal to 40. Then we execute line 2. Line 2 shows move BX 5. This instruction loads the value 5 into register BX, and then after execution we see that BX equal to 5. Okay, next we execute line 3. Line 3 shows multiple BX that AX multiplied by BX. Okay, after AX multiplied by BX, AX is 40 and BX is 5, then shows the line 3 equal to 200 after multiplication. Then the multiplication result is stored in DX AX register pair. Okay, next we go to the line 4. Line 4 shows move BX var2. var2 is equal to 10, right? Then after execution we see that BX equal to 10. Then line 5 subs BX 3. Then what's that mean? We must to subs the line 4 10 sub to 3. Then we get BX equal to 7. Okay, then we goes to the line 6. Line 6 shows divide BX. Divides BX is DX AX equal to 200, right? Then we divide by 7. 200 divided by 7, we get 28, remainder 4. 28 remainder 4, and then AX stores the quotient and DX stores the remainder. Next we move to the line 7 that shows move var4 AX in the line 7. So since AX equal to 28, And then after execution, we get var4 equal to 28. Then last but not least, we execute the last line. Then after we execute, in the window shows that var1 equal to 40, var2 equal to 10, and last but not least is var4 is equal to 28. Okay, so we move to the question number 6. At the line 1, shows that move dx 0. Declare dx to form the 16-bit dividend in dx ax. So after we execute this line 1, we get dx equal to 000h. Then at the line 2 shows that move ax 803h. This instruction loads the hexadecimal value 803h into ax. Then hexadecimal conversion 803h equal to 2051 decimal. Then after execution, we get ax equal to 0803h and dx equal to 0000h. Then the dividend is now stored in dx ax. So dx ax equal to 0803h, then which equal to 2051 decimal. Then we continued in the line 3, shows that move bl 10h, and after execution we get and this instruction loads the divisor into this register bl equal to 10h, and decimal equivalent 10h is 16 decimal. So divisor is equal to 16. So at the line 4 shows that divide bl. This instruction divide ax by bl, then ax equal to 0803h equal to 2051 decimal. Then bl equal to 10h equal to 16, and after we calculate, we get after calculate 251 divide by 16, we get 128, remainder 3. Okay, so therefore al equal to 128 equal to 80h hexadecimal, and ah equal to 3 which 03 hexadecimal. So ax become 0380h. Okay, so at the line 5 shows call dumbbreaks. Dumbbreaks displays the contents of all CPU register on the console screens. So plain text like EBX, EAX, ECX, EDX, ESI, and so on. So at the this help verify whether the division produce the correct result. Okay, so next exit. This instruction terminate like the program and return control the window. And line 7 next, main NDP and end main. Thank you.